Good day to you, Panther students. It is currently 3:01 in the morning. Like I said in our group meeting last week, my sleep schedule is all kinds of messed up right now. But that's just how it goes, I guess, during the pandemic. So we're going to pick up where we left off with angles, and like I said, we're going to throw some equations into the mix, and then that should be, I'm gonna turn this down a little bit for myself. We are going to throw some equations into the mix and combine what we've learned about vertical angles and what we've learned regarding equations with variables on both sides. Okay, so let's start with a quick warm-up. So what is the measure of angles J and K? Okay, and if you have not checked out the video on vertical angles, I would strongly suggest that you give that a watch before you move on to this one. Okay, so what is the measure of angle J and angle K? Okay, well, angle J is vertical or opposite to this angle right here. Okay, 91. So that means they are going to be identical. Okay, so if this angle here is equal to 91 degrees, that means that angle J is also, I don't know why I did that, that means that angle J is also equal to 91 degrees. Okay, and then angle K and this angle that we are told is equal to 89 degrees, those are also vertical. Okay, or opposite, which means that if this angle here is 89 degrees, the angle opposite of it is also equal to 89 degrees. So equal to 89 degrees. Okay, and there we go. It's as simple as that, folks. And if we take a look down here at the bottom, okay, what does it mean for two angles to be congruent? Okay, or anything to be congruent. In other words, the word congruent is a fancy way in mathematics of saying that two or more things are what? Well, it means that two or more, it could be angles, it could be side lengths, it could be areas or perimeters. If two or more things are congruent, that is a way in mathematics of saying that they are, how about a dark green? That means they are equal. Okay, or the same. Okay, so if two angles, side lengths, areas, perimeters, values, whatever it is, if they are congruent, that means they are the same or they are equal. Okay? And we're going to be using that term in this video, so make sure that you go ahead and store it in the short-term memory for now, and then we will hopefully get it into the long-term memory by the time we are done with this unit. Okay, so today we are focusing on equation practice with angles. Okay, and if you are a Panther student from the 2019-2020 school year, you are going to want to, in your interactive notebooks, turn to your notes that have to do with equations with variables on both sides. Okay, and the goal for today is, we're going to spend a little bit of time at the beginning. The first few slides are dedicated to naming and identifying angles. which I know some of you might know and be familiar with already, but just in case you aren't, I want to spend a little bit of time going over it. Okay? And then I want you to be able to solve angle measurements when the given information is in the form of an equation. Okay? So if instead of being told that this angle here is 91 degrees, if it were in the form of an equation, and we had an equation over here, could you solve for the angle measurement? Well, if you are good with equations, then this is a little bit more of the same. If not, don't worry, we're going to go over step by step how to, use inverse operations to cancel out terms on sides of an equal sign. I'm not going to go over why, the steps work the way they do for equations, because it's something we have covered over and over and over again. I guess I will go over it at the most basic level, but I'm not going to pause and spend a great deal of time talking about it. Okay, so let's talk about naming angles. Okay, so when naming an angle, the letter representing the vertex must be in the middle of the name. Okay, so all of these angles that you see here on the screen have names. Okay, they're 3-letter names. So, for example, this angle right here, we would call this, we can call it one of two things. Okay, we can call it angle A, and then, so A, E, B, or we can refer to it the other way around. We can put B in the front, E stays in the middle, and A moves to the other side. Okay, so this blue angle right here, we can refer to it as angle A, E, B, or the other way around, B, E, A. Okay, and again, that part about the vertex, okay, or the point where the two lines meet to form, for lack of a better term, a corner, okay, that is going to be the letter that needs to be in the middle. Okay, so see how we have this line here, okay, and we have this line here, and where do they meet? Well, they meet right here at point E. So E is going to be our vertex, and that means that needs to be our middle letter. Okay? Let's do another one. And let's move on. Let's see. Let's do this one down here. Okay, so this angle right here. So go ahead and pause the video for a sec and see if you can write down one of the two names that we could name this angle right here. Okay, I'm going to assume that you either tried it or the first example wasn't enough. Okay, so we have two options. We can start right here and label this as angle CED. Okay, or we can start down here with DEC. Okay, so our two options are we can call it CED, or the other way around. We can put D in the front, E as the corner or the vertex, okay, the point where the two lines come together, is in the middle, as always, okay, and C at the end. Okay, and either way, is perfectly fine. Okay, so at this point, we should all be able to name this angle right here. Okay, and just go ahead and give me one of the two names this time. So go ahead and pause it and have the name in your mind. Okay, so our two options are, okay, we can go with B, E, C, which is what I would personally go with, just because I like to work from left to right. Okay, so this could be B, E, C, okay, or the other way around, we can start here and do C to E to B. Okay, so that would be the same thing but backwards. So C, and then E, and then B. Okay, so we have labeled these angles right here, all three of them, but there are other angles here that we could name. Okay, so it's not just these three segments. Let me kind of revert back here. What if I asked for the name of this angle right here, so it stretches across both of them? Okay, how would that work? Well, it would work the same way. You just would need to, for the time being, pretend that this line is not there. Okay, so if this line were not there, what names would you come up with? Okay, would you go A, E, C, which is a perfectly fine name for it. So you could do A, and then E, and then C at the end. Okay, or are you a rebel? Someone who likes to work backwards through these kinds of things. Okay, and do C to E to A. Well, no matter which of these two ways you select, you would be correct. Okay, so even if, like in this problem here, even if we have another arrow, okay, or another line, cutting through this angle, the name is still the same, whether this is here or not. Okay, we would still refer to this as angle A, E, C, or angle C, E, A. Okay. What about these two right here? Or what about this angle right here? What would we call this angle? Okay. So again, two choices. We can call it B, E, D. We can call this bed. So B to E to D. Or, as always, we can do it the other way around. It could be angle bed, or it could be angle Deb. Okay, which would be starting here, so D, E, B. Okay, so you're basically, just like last time, pretending that that is not there, okay, when you're naming the angle. Okay, so don't be thrown off by the extra arrow. I'm trying to find it again. There it is. Okay, and we have one more possibility for now that I'd like to go over. What if I wanted the name of this whole thing, okay, the entire angle, okay, all the way across? Okay, I'm making this worse the more I try to color it in. So if I wanted everything across from here to here, what would that angle be? Okay, well, once again, you'd like to, pretend that these aren't there for the time being. Okay, when you're just looking at the name. Okay, so we could go with angle AED, or other way around, we can call it angle DEA. Okay, and the same thing is true, even if the lines are there, okay, it does not change the fact that this is either angle AED or DEA. Okay, so we're going to, practice a little bit with identifying angle measurements. Okay, we'll start right here. Okay, so angle JZY is equal to how many degrees? Okay, well, let's go up here. So JZY, so J, Z, and Y. Okay, and the angle measurement between them is 40 degrees. So we would say that this angle has a measurement of exactly 40 degrees. Let's go ahead and move down. We'll work in columns, okay, top to bottom. Okay, so we have YZW, so angle YZW, so that would be Y to Z to W. And the angle right here in between, okay, looks to me like it would be 50 degrees. So that would be equal to 50 degrees. Angle XZY. So X, Z, and Y. So this is where things change just slightly. So angle X to Z to Y. Okay, so we want the whole thing now. Okay, we want all of this. Okay, so if we want the exact measurement, what we're going to have to do is we are going to have to add both of these together. Okay, we know that this part of the angle is equal to 40 degrees, and this part right here is equal to 59 degrees. Okay, so the distance all the way across is going to be both of those added together, meaning we are going to end up with a total of 99 degrees. Okay, next one. KZY. Okay, so KZY. Okay, and once again, we have a bigger angle, okay, that has two smaller angles inside of it. Okay, so we want this distance. Let's use red. So we want this distance all the way across. Okay. Well, we know that this portion of the angle right here is equal to 31 degrees. Okay, and the rest of the way across is equal to 50 degrees. Okay, so if we want the entire angle, we're going to add both of these together. So 50 degrees plus 31 degrees is going to be equal to 81 degrees. Okay. Nothing too fancy here. Okay. Let's move to the next one. JZK. So that's going to be, so angle J to Z to K. So now we're talking about an even bigger angle. Okay, look in between these. Instead of having two segments, now we have one segment here, another here, and a third one right here. Okay, so if we want the distance all the way across, okay, from line J to Z and then line Z to K, we're going to have to add all three of these guys together. Okay, so 40 plus 50 plus 31. okay, I believe is 121. Okay, and just to double check our answer, let's type it in. So 40 plus 50 plus 31 is equal to 121. Okay, so the distance all the way across angle JZK is equal to 121 degrees. Okay. We've got one more to go here, folks. So angle XZK. This is probably going to be the weirdest one out of all of them. So X, Z, and K. This time, we want the distance across all of these. All 1, 2, 3, 4 angles. Okay? So we know that this chunk right here is equal to 59 degrees. This chunk right here is 40 degrees. This next part is 50 degrees. And finally, our last part here is equal to 31 degrees. So if we want the measure of angle XZK, we're going to have to add all of these together. Okay, 59 plus 40 plus 50 plus 31, I believe, is 180. So 59 plus 40 plus 50 plus 31 is equal to 180 degrees, which means that angle XZK is what kind of angle if it's equal to exactly 180 degrees? What kind of angle equals exactly 180 degrees? That's right, it's a straight angle. Okay, and if all of these angles add up to exactly 180 degrees, that means that these angles are supplementary angles. Okay, because they add up to exactly 180 degrees. If they added up to 90, they would be complementary. But because they equal 180, that means they are supplementary. Okay? So all of this is laying the groundwork for being able to identify and name angles. Okay? Because you're going to be seeing, especially those of you who are moving on to high school geometry, you're going to see a bunch of angles, and the problems aren't going to have them color-coded. Okay? They're going to have names like down here. Okay? And you have to be able to identify them. And quite frankly, it's a skill that your geometry teacher is going to expect you to already be proficient with going into the class. Okay, so he or she will expect you to know it going in. Okay? All right. Let's get to the main course here. Okay, we are going to solve for the measurement of an angle, and we are going to deal with angle measurements that are given to us, okay, with variables, okay, instead of exact specified degrees. Okay, so let's take a look here at our given information. Okay, we know that angle AEC, okay, so angle AEC, which is this one right here, AEC, okay, we know that this angle here is equal to 4x plus 66. Okay, and angle DEB, or DEB, is equal to 7x plus 15. Okay, and the problem is asking us what is the measure of angle AEC? Okay? So we need to know what x is equal to in order for us to figure out the exact measurement. Okay? So, this is where things are going to get a little bit different. Okay, but I'm fairly certain that after the first example, when we move to the second example, it should make a little bit more sense. So if you're lost after this one, that's okay. There's another example coming up. Okay, so what do we know about these two angles right here? Okay, they share the angle relationship that we discussed in our last video. Okay, they are vertical. Okay, and what do we know about vertical angles? Well, from our bell ringer, we know that vertical angles are congruent. Okay? So whatever this equals, that's what this equals. Okay? So congruent, remember, is a fancy word of saying that two values are equal to each other. So what we're going to do is we are going to set both of these equations equal to each other. Okay, and we're going to set both of these expressions equal to each other. And what we're going to do is we are going to solve for x. Okay, so let's do that. So we have an equation with variables on both sides. Do we have any like terms to combine on the left? I don't see any. What about over here on the right? Any like terms to combine over here? No. So what that means is we then need to cancel out one of the variables on one of the sides of our equal sign. I'm going to cancel out the smaller of the two. Okay, so this positive 4x, I'm going to cancel it out by subtracting it. Okay, because 4x minus 4x equals 0, which means we get to cross it out. Okay, and then I'm going to subtract 4x from this side too, because whatever you do to one side of an equation, you must do it to the other. So that means we're going to have 66 is equal to 7x minus 4x, which is 3x. And then the plus 15, we didn't do anything with, so it kind of just moves straight down. Alrighty. So now we have a two-step equation, and we need to isolate x over on the right-hand side of the equal sign. So let's cancel out the other two numbers, and we'll start with the 15. Okay, this is a positive 15. If I want to cancel it out, I would subtract 15 from both sides. Okay, positive 15 minus 15 equals 0. So that cancels out, leaving us on the right-hand side with 3x. Okay, and that's equal to 66 minus 15, which is 51. We're almost done here. We've got one last number to cancel out. So the 3 and the x are right next to each other with no sign in between, which means they are being multiplied. So to cancel it out, we have to do the opposite of multiplication, which is division. So let's divide both sides by 3. These cancel out, and that leaves us with x is equal to 51 divided by 3, which is, write it here in brown, which is 17. Okay, so x is equal to 17. Now, that's not our final answer, okay? If the problem over here had asked, what is x equal to, then we would be done. Okay, but it is asking us, what is the measure of angle AEC? So we're focused on this angle right here. Well, now we know what x is equal to. Okay, now we know what x is equal to. So we're going to plug it in right here. So if x is equal to 17, that means we now have enough information to figure out the measure of the entire angle. So instead of it being 4 times x plus 66, it's going to be 4 times 17 plus 66. Okay? 4 times 17 is 68. Okay, so we get 68 plus 66. Okay, and 68 plus 66 gives us a total of, I believe, 134. Let's double check. 68 plus 66. 68 plus 66. Yes, 134. Okay, so the measure of angle AEC is equal to 134 degrees. And that, ladies and gentlemen, is our final answer. Okay? So what did we do here? Well, we took the information that was given to us by the problem. Okay, it told us that angle AEC was equal to 4x plus 66. BED, or angle DEB, is equal to 7x plus 15. And then what we did was we set both of these expressions equal to each other. Right? Because they are vertical angles. So we know that vertical angles are congruent or equal. So that's why we were able to set them equal to each other. And from then on, this problem changes from being a geometry problem to being an algebra problem. Okay, we use inverse operations and the skills that we've learned in solving equations to solve for x. Then we plug x in for our variable and just followed the order of operations, and we got 134 degrees. Okay? Alright, let's do one more, because this video is already running a bit long. Okay, so let's take a look at the top. It says, find the measure of angle HVO. Okay, so the measure of angle HVO is that angle right there. And we know that it's equal to 5 times x. Well, that's a bit of a problem, because we don't know what x is. So it's 5 times whatever x is. So in order to find the exact measurement, we need to find out what x is equal to. And we're going to need the help of our vertical angle right here in order to figure out what x is equal to. Okay, so let's do the same thing we did last time. So we know that vertical angles are congruent, okay, or equal. Let me change the color of this to something a bit easier to see. Is that easier to see? I don't think it is. There we go. So we know that this angle here, which is 5x, is going to be equal to this angle right here, which is 2x plus 24. Okay, so we've set them equal to each other. We check both sides to see if there are any like terms to combine. I don't see anything on the right, and there's definitely nothing here on the left. So now let's go ahead and get, or cancel out one of our x's. Okay, we're going to cancel out this one. So if we cancel out this one, that's going to cancel out one side of our equal sign. Okay, and we don't want that necessarily. Okay, not yet. Okay, so positive 2x minus 2x equals 0, so we cross it out. 5x minus 2x is 3x, and that's going to be equal to 24. Okay, and the last step, let's cancel out the 3 and the 3 next to the x. They're right next to each other, which means multiplication. So we are going to divide to cancel out the 3. Okay, so those cancel. So we get x is equal to 24 divided by 3, which is 8. Okay, so we know that x is equal to 8, and now we could figure out what the measure of angle HVO is, okay, by plugging 8 in for x. So instead of it being 5 times x, let's make it 5 times 8. And 5 times 8 is equal to 40. Okay, so the measure of angle HVO is equal to 40 degrees, ladies and gentlemen. Okay? And that's going to be our final example for this video. As always, if you have questions, feel free to leave them in the comments or post them in Google Classroom or email them to me. Let me know how this one goes. I know it combines a lot of topics together, okay, but a lot of the work with equations, again, we have done many, many, many times, okay, so open up those interactive notebooks. Watch the videos in the Khan Help section, okay, if you need a third example, okay, and if you are lost, let me know, and we can look into, you know, some kind of tutoring through streaming. Okay? Alright, that's where I'm going to leave it, folks. Thank you very much for your time, and I will talk to you soon.